Hi, and welcome to lesson 101.1 of Plutus Project-Based Learning 2024. This is a course from Gimbal Labs and Friends where you can learn Cardano development, and in this video, you'll see how to compile your first smart contract from Plutus TX. Before we take a look at how to do that, let's do a quick review of what you saw in the previous module. If you were successful, you were able to connect your wallet to Preprod, mint a token, and then interact with this PPBL faucet validator. Now, in Module 101, you're going to start to learn how this validator works. Now, what's a validator? You might have heard the term smart contract, but on Cardano, the word validator is actually more important to understand. And this is a topic that we will cover in depth throughout this course. For now, here's what you need to know. By writing a validator, we can create custom rules about how assets are unlocked from an address on Cardano. There's a lot of details to unpack in what I just said, and that's what we're going to do over the course of the next few lessons. To start, let's take a look at some validator code, and let's look at what it means to compile that code so that we can turn it into an address, like the one that's used here. To get started quickly, we'll use a platform called Demeter, and you can access it here at demeter.run. Now, there's a few reasons I love Demeter. One is that it makes it really easy for anybody to start exploring different parts of the Cardano development stack. And I'm not going to go into detail on everything you can see right here, but there's a lot of resources to help people get started. Also, there's a list of starter kits, and these provide even more specific ways for you to start building some useful applications on Cardano. One of the starter kits is related to this course. You can find it down here, PPBL 2024 Plutus Examples, and this is what we're going to use today. Now, before I can deploy this, I have to log in. And I'm going to leave that part to you. Tap the sign in button and make an account by whatever means you'd like. Once you're logged in, keep going with this video. Now that I'm successfully logged in, I'm ready to keep going. I can simply tap this Deploy in a Project button. And I already have a project here called PPBL 2024. If you don't have one yet, you can simply create a new one. I'll deploy it. And now it'll take a few minutes to provision the project. You can see there's a status here, preparing your workspace. And we're back. You can see that my workspace is running. It took a little bit more than 5 minutes for this workspace to be ready to go. You can see that my uptime is a little bit beyond that right now because I looked away for a moment while it was finishing up. But we're ready to go when you can see that your workspace is running. And if you were paying attention, you might have noticed that some parts of this process took longer than others. For example, setting up the Cabal cache is what took the longest for this to set up for me. The important thing to recognize is that now there's a virtual machine running with a whole bunch of helpful software on it. And while it's possible to set up all of this software on your computer, and you should do that eventually, we're not going to do that right away. If you're really interested in setting up a Plutus development environment on your computer, definitely let us know. We can do a special live coding session about that if there's demand for it. But for now, let's take a look at what we've got here. I'm going to click on the VS Code icon right here. If you're not familiar with Visual Studio Code, it's popular software for editing code on your computer, and there's a version of it right here where we can use it in the cloud right here in our web browser. Now, Gimbal Labs are the authors of the code that we're going to use here, so yes, I'll trust us for now. Now, right here in my browser, with all the tooling I need already provisioned, I can review all of the code from the PPBL 2024 Plutus examples repo. This is linked right here. Here's the source. And there's also a link to this repo on the main page of plutuspbl.io. Course repositories, Plutus examples, takes us to the same link that we're looking at in the browser right here. Now we can take a look at what some validator code looks like. Let's go to the source directory and then faucet. Let me zoom in a little bit. In the faucet directory, there are 3 .hs files. These are Haskell files. And when you write Plutus TX, you're actually writing in a Haskell file. Because we're just getting started, we'll follow the recommendation here to choose automatically. And now we can take a look at some validator code written in Plutus TX for the first time. Even if you've never read Haskell code before, I invite you to take a look. Right here, we have a function called treasury validator. It takes 4 arguments and it outputs a Boolean, true or false. These arguments are the faucet parameters, the faucet datum, the faucet redeemer, and the script context. These first 3, params, datum, and redeemer, are defined in the faucet.types file, which we can find right here. Let's open that. Faucet params consists of 2 currency symbols. Faucet datum includes an integer called withdrawal amount and the name of some token. And the redeemer takes what's called a public key hash and a token name. Don't worry about the details too much. We're going to look at these details in depth later in the course. For now, I just want you to get a feel for the shape of this code. Going back to the validator, we can see also there's something called script context right here. So script context is what allows us to look at some of the details of a transaction when this validator is doing its job. Now, what's the job of this validator? It's to return a Boolean, true or false. If the validator returns true, that means that we can spend tokens locked in this validator. If it returns false, then we can't. Compare this to spending tokens from a regular Web3 wallet. If I have the password for my Nami wallet, for example, I can spend tokens from that wallet address. If I don't have the password, I can't. Validators offer an alternative to the way that wallets typically work. They allow us to define custom logic for how tokens can be unlocked from an address on the blockchain. There's a bunch of helper functions defined here. Many of them return true or false, a Boolean. And at the end of this function, we collect 5 of these Boolean functions and we say, okay, if all 5 of these things are true, input has access token, output has access token, output has faucet token, faucet contract gets remaining tokens, and check datum, all of which are defined above. If all 5 of these things are true, then the validator will return true. If any of these things are not true and we're using the right tooling, we'll get error messages related to which of these constraints were not met. We will take a closer look at these error messages in Module 102. For now, just take this in, and thank you for taking a look. This is a validator. Validators are a really big deal. And once we have validator logic like this, we can use it in an application like this one. What I'd like to cover in the rest of this lesson is how to go from source code like this to the sort of code that we can actually use on the blockchain. Here's how to do it. In Visual Studio Code, if you hold down the Control key and tap tilde, you'll be able to see the terminal window. And this is where Demeter really helps us out. The process of getting to the step I'm about to show you on a local computer is a little bit complicated, and we'll help you get there. But by getting started on Demeter, we can skip right to the end result. There are two commands we will need to run. The first one is Cabal update. The first time you run this, it might take a few minutes. Cabal is a package manager for Haskell, and by running Cabal update, you'll make sure that your packages are up to date, just like you see here. The next command we'll run is Cabal REPL, which loads a live REPL that we can use to run some functions in our Haskell code. The first time you run this, it might take a while, so give it some time. And if you're successful, you should see a prompt that looks like this, ppbl.alwayssucceeds. If this doesn't work the first time that you run Cabal REPL, try running it again. We're working with the TX pipe team to make sure that this entire repository is cached, but you might run into a problem where the virtual machine runs out of memory the first time you run Cabal REPL. If that happens, just run it again, and you should be able to get to the point where you can see what I see on my screen, ppbl.alwayssucceeds. Now I need to step back for just a moment. There's a lot that I want to show you right now, but I don't want to completely overwhelm you with all sorts of new information. So I'm going to go through a couple of really important points while leaving out some of the details. And I hope that what I show you right now gives you enough to tinker with, and if you have questions, that you'll be sure to reach out in the Gimbal Labs Discord or at our regular live coding sessions. You can find details about all of this at the Plutus PBL website. Okay, there's a link to Discord right here on the home page, and there's a link to our calendars with different live sessions here. So I'm not going to cover absolutely every detail right now, but let's do just enough so that you can play around with a couple of other things here. First of all, ppbl.alwayssucceeds. Where does this come from? Let's look at our file structure for just a second. In the source directory, there are three subfolders: ppbl, faucet, and contributor token. Now, inside of the ppbl directory, there's a file called Always Succeeds, and that's where we're getting this prompt from, ppbl.alwayssucceeds. If I open this file right here, you'll see this module has a name that matches the directory structure right here. And finally, if I take a look at the ppbl 2024 Plutus examples.cabal file, and I scroll down to the bottom, you'll see that the following modules are exposed in this project. And the first one in the list is ppbl.alwayssucceeds. So put it all together. We expose the module, we give the module this name, and we create a directory structure to match, put it all together, and now we have access to these functions here inside of our REPL. But this lesson is not about Always Succeeds, so we're going to leave this one alone for right now. This lesson is about the faucet. Now, the faucet directory has three different files inside. It has faucet.validator, defined in this file. It has some types defined here, faucet.types, which by the way is imported here in the validator. And then there's a separate file that handles compiling these validators. It's called faucet.compiler. Faucet.compiler exposes a function called write faucet validator script, which is defined below. And if we take a look at that .cabal file again, we will see that all three of these modules are exposed. I'd like to run the write faucet validator script function right here. What this is going to do is write a validator to the output directory called myfaucetscript.plutus. Now, because I've done this already, there's an output directory here. And you can see the results of running this function earlier. They're included in the repo. Let's just change the file name here. I'll just make it -002, just so we can compare the results here to the previously compiled results that you'll find right here. If for whatever reason you don't have an output directory yet, just make one. You can use the button right here to create a new folder. And if you don't have these files, don't worry about it. You'll be able to create them on your own. I'm going to save this file with this new file name. And then I'm going to reload the REPL by pressing :R down here in the terminal. This will make sure that the most recent version of this compiler, the one where I've changed the name of this file, is working right here. Next, I have to load the module that I actually want to use. Here's how to do it. I can type :L for load, and then I can start typing faucet with a capital F. If I do, I can press Tab to complete, because the REPL knows which modules are available to me. Then if I type C and Tab, it will continue to autocomplete. And this says right here that I'm going to load the faucet compiler. Let's do it. Good. It's loaded. In fact, 3 modules are loaded. Yeah, it had to load all 3 of these modules, faucet.compiler, faucet.types, and faucet.validator, because you can't use one without the other. The validator and the types are imported right here. Now that faucet.compiler is loaded, I can use this function, and once again, autocomplete will work. I'll just type the word write, and then I'll press Tab to autocomplete. There it is, write faucet validator script. You'll notice that it didn't try to autocomplete to write validator, and the reason for that is write validator is not exposed here on line 4. We're only exposing write faucet validator script, and so that's an easy choice in our REPL for the auto-completion to work. When I run this script, it's either going to create an error or it's going to work. If this syntax is brand new to you, don't worry about it too much right now, but just notice that the error is on the left, and this unit, right, these empty parentheses are called a unit in Haskell, is on the right. So if this function runs successfully, in the REPL we'll see a message that says write, and in the output directory up here, we should see a new file with this file name. Let's see if it works. So it says write, and then there's the unit from right here. And indeed, our new Plutus script is right here. Let's take a look. This is the on-chain representation, the byte string that represents the validator whose logic is written right here. Okay? We just compiled what's called Plutus TX to a byte string representation, which is called untyped Plutus core. you might hear these letters, UPLC, to describe the actual code that's used on the blockchain. This is it right here. If you got this far successfully, congratulations. You just compiled your first Plutus validator. In this lesson, this is actually where we're going to stop. We're not quite going to show you what you can do with this validator until we get to module 102. But to begin, just recognize that the output of everything we've done here with Plutus TX is this file. It's actually a JSON object, right? With opening and closing curly brackets. It has a type. It says Plutus script v2. It has a description, which is just an optional string. And I could add to this the faucet validator from PPBL 2024, for example. And then this byte string, which is the code that we're actually going to be able to use on the blockchain. In the next lesson, you'll see how to generate a file that looks just like this one, but instead of starting from Plutus TX like we did here, we'll start from another on-chain programming language called Aiken. Then, in module 102, you will start to learn how to use the code right here on the blockchain. There's a lot to be excited about, and I'm glad you're here for it. Before we wrap, one more thing. In the compiler over here, you can see that we can define some faucet params. What are faucet params? Let's come full circle back to where we started in the types module, where faucet params are defined like this. To create a faucet, I need to provide an access token symbol, which is the currency symbol of a token on Cardano, and a faucet token symbol. Then, in the compiler, I can give specific values to each of these right here. We're going to revisit this concept in the upcoming lessons. First, by looking at similar functionality. Where do the parameters go in Aiken, for example, is something that we'll look at in the next lesson. And then when we start to build transactions, it'll make a little more sense what these two parameters are doing. And after we have a chance to play with some transactions, we will come back and we will change these parameters to learn more about what the implications of changing validator parameters are going to be. But this video has already been a marathon, and if you watched to the end, thank you. I'm proud of you. I'm glad you're here for this, and I'm so excited that we get to keep learning together. You probably have questions. Make sure to bring them to the Gimbal Labs Discord or to Live Coding, and I'm eager to see what we do next in this course. See you soon.